Hey everyone, welcome back to MTechZudo, your space for learning tech in the simplest, smartest way possible. In our last episodes, we talked about IP addressing and how every device needs a unique address to communicate on a network. But here's the question, with so many devices connecting every second, who actually assigns those IP addresses? Well, that's the job of DHCP. The Dynamic Host Configuration Protocol, and today we will see how it works step by step. Now, the problem before DHCP. Imagine this, you are setting up a new office network with 100 computers. Without DHCP, you would have to manually enter a unique address for every single computer one by one. Not just that, you would also need to configure subnet masks, default gateways and DNS servers. That would take forever. And one small mistake could crash the whole network. So, the tech world came up with an automatic solution, DHCP, which assigns IP addresses to devices automatically. Now, what is DHCP? DHCP stands for Dynamic Host Configuration Protocol. It's a network service that automatically assigns IP addresses and other network settings to devices when they connect. Think of DHCP as your network's address manager. It gives every new device a unique address the moment it joins the network. That means your phone, laptop, printer or smart TV all get their IPs without you having to touch a single setting. Now, how DHCP works? Alright, let's understand how DHCP actually works behind the scans. The process happens in 4 simple steps, known as the DORA process: discover, offer, request, acknowledge. Let's break it down. First, DHCP discover. When you connect your device to the network, say you join a Wi-Fi. Your device doesn't have an IP8, so it sends a broadcast message called DHCP discover across the network, asking, is there any DHCP server out there who can give me an IP address? Now, step 2. DHCP offer. The DHCP server receives that message and replies with a DHCP offer. It offers an available IP address along with other details like subnet mask, default gateway and DNS server address. Now step 3. DHCP request. Your device then responds with a DHCP request saying, yes, I would like to use the IP address you offered me. This tells the server which offer it's accepting, especially if there are multiple DHCP servers on the network. Now step 4. DHCP acknowledge. Finally, the DHCP server sends a DHCP acknowledge message confirming that the IP address is assigned and ready to use. And that's it. In just a few milliseconds, your device now has an IP address, gateway and DNS info all automatically. Now, DHCP lease and renewal. Here's something interesting. IP addresses assigned by DHCP are not permanent. They are given out for a specific time called a lease. When that lease is about to expire, your device automatically sends a renewal request to keep the same IP. If you disconnect too long, that address goes back to the pool and can be given to another device. This is how DHCP ensures efficient IP usage in big networks. Now, why DHCP is important? Without DHCP, managing networks would be a nightmare, especially in offices, schools, or data centers where hundreds of devices come and go daily. DHCP saves time, prevents IP conflicts, and keeps your network running smoothly, automatically, and silently. It's one of those background heroes that most people don't even know exists. Now, real world analogy. Think of DHCP like the reception desk at a big company. When a new visitor arrives, the receptionist gives them a temporary visitor pass. That's your IP address. When they leave, that pass is returned and can be reused for the next visitor. Simple, organized, and efficient. That's DHCP in a nutshell. And that's how DHCP works, from discovering the network to automatically assigning IP addresses in milliseconds. No manual setup, no confusion, just smooth automated networking. If this helped you understand how IPs are assigned, hit like, subscribe, and turn on notifications to keep learning with MTechZudo. Thanks for watching, and as always, keep learning, keep exploring, and keep growing.